In this video, we will learn about colloids and suspensions and explore some of their properties. The starting point for understanding suspensions and colloids is understanding mixtures. A mixture is simply the combination of two or more different chemical substances that aren't reacted together. In a chemical mixture, the substances generally retain their original chemical behavior. Mixtures can be homogeneous or homogeneous with a composition that's even throughout, or they can be heterogeneous with a composition that varies depending on where you look. Another term we use when talking about mixtures is the word stable. Mixtures can be stable with a composition that's consistent over time, or unstable, where the composition changes with time. Suspension and colloid are yet more words we use to describe certain types of mixture, but before we look at these categories, let's recap what a solution is. A solution is a mixture of one or more substances dissolved in another substance. The dissolved substances are known as the solutes, and the substance they're dissolved in is called the solvent. If we have two or more substances that are mixed together on the atomic scale, we have a solution. We're familiar with solutions like soda, ocean water and nail varnish remover, but solutions don't need to be liquids, but we'll look at some more examples later. Colloid and suspension become important terms when we go beyond the scale of a few atoms and the lumps of substance get a bit bigger. Colloid is the name we give to a mixture where we have slightly larger lumps of substance in a continuous medium of another. Typically, the diameter of the particles in a colloid will be between 1 and 1000 nanometers. By definition, colloids are homogeneous. They have a consistent composition throughout. When we're talking about colloids and suspensions, we do need to zoom out a little when we're talking about composition. We'll take an average over a slightly larger area than when we're talking about solutions. And by definition, colloids are also stable. They do not on their own separate out. We can destabilize a colloid in some ways, but we'll come to that later. The substance or substances that are spread in microscopic lumps throughout the medium are called the dispersed phase. And the continuous medium that surrounds them is called the dispersion medium. So, the dispersed phase is dispersed throughout the dispersion medium. We'll look at some examples in a moment. The terminology for a suspension is very similar. We still have a dispersed phase and a dispersion medium, but the particles tend to be a bit bigger. The key difference between a suspension and a colloid is that suspensions are unstable. The lumps of substance eventually clump together and form areas of high concentration, leaving areas of low concentration behind. Therefore, suspensions are also by definition heterogeneous. The composition of the mixture is not consistent when we look in different places. Next, we'll look at some examples of solutions, colloids and suspensions. When we make mixtures, we generally mix a solid, a liquid or a gas with another solid, liquid or gas. As we populate this table, solutions will go into the bottom, colloids will go in the middle, and suspensions will go in the top. So along the top, we either have the solute or the dispersed phase, and along the left-hand side, we have the state of the solvent or dispersion medium. Solids tend to be stable over long periods, so we don't tend to think about solid-solid mixtures being suspensions, but they can be colloids. For instance, coloured glasses can be made by introducing very small particles of other materials into glass. And it is possible to have solid-solid solutions. For instance, alloys will be made of different types of metal blended together on the atomic scale. Next, we'll look at liquid-liquid mixtures. Oil and water are two liquids that don't naturally mix together. However, if you shake them up, you can get tiny droplets of one phase in the other. Milk is a colloid of various fats and proteins suspended in water. We can call milk a colloid because it actually undergoes chemical changes when it goes sour. The stuff we start with can be considered stable on its own. And our example of a liquid-liquid solution is vinegar, which is a mixture of ethanoic acid or acetic acid and water. There are fewer varieties of gas-gas mixture. By definition, a gas is made of separated particles, so we can only form a solution and not a colloid or a suspension. We can describe air as a few different gases dissolved in nitrogen. We consider nitrogen the solvent simply because it makes up the majority of the air. What about the other combinations? Blood is a good example of a solid dispersed in a liquid. Various types of cell are suspended in water, but they will separate out over time. We can see this when we centrifuge blood, separating it into various layers. Meanwhile, inks are good examples of solid-liquid colloids. They are often made of solid particles dispersed in water. And for our solution, we have sugar water. Sugar, which is normally a solid, dissolved in water. But we can, of course, have liquid-solid mixtures. Suspensions of liquids in solids aren't that common, but there are examples of colloids like jello. Water dispersed in gelatin. And we can also have liquid-solid solutions, like mercury mixed in with solid gold. Next, we have gases and liquids. We can get suspensions of liquid in gases by using a spray bottle. But we can also form liquid-gas colloids, like mist. Under the right conditions, very small droplets of water are stable in the air. And the only way of making a liquid-gas solution would be to evaporate the liquid, turning it into a gas, so that doesn't count. Instead, let's look at gas-liquid mixtures. In bubble bath, we get foam, which is thin films of soap and water surrounded by air. But those bubbles quickly collapse. If we want a stable foam, we need smaller bubbles, like those in shaving foam or whipped egg whites. And for our gas-liquid solution, we have carbonated water, carbon dioxide dissolved in water. And finally, we have the slightly less common mixtures of solids and gases. Dust in the air is a solid-gas mixture that's unstable. It's a suspension. But finer particles like those in smoke can form colloids which are stable. But just like with liquid gas mixtures, we can't have a solid gas solution. We don't tend to think of gas-solid suspensions. Instead, the solid is considered a stable structure, so we can form colloids. A good example of which is plastic foam. And it is possible to form gas-solid solutions. For instance, palladium is a heavy metal that will absorb hydrogen gas. These are just some examples, and some people may disagree about which ones are actually colloids or suspensions. When we have a solid suspended in a gas, it can have a special name, a solid aerosol. And mist is an example of a liquid aerosol. Collectively, these are known as aerosols. Next, we're going to look at some of the key properties of colloids and suspensions. Water is colourless, and fats and oils tend to have very little colour, maybe a little yellow. So, why is milk, which is a mixture mainly of fat and water, white? Milk does contain other substances besides fat and water, but none of these are strongly coloured. Milk is a colloid, with globules of fat suspended in a continuous medium of water. The water is the dispersion medium, and the fat and other chemicals are the dispersed phase. When light passes through milk, the light is scattered. This means all the colours of light hitting the milk are averaged out, and we get something that looks white. Now, the Tyndall effect is a special phenomenon we see with colloids and some very fine suspensions, but this is not the Tyndall effect. Instead, the Tyndall effect is about how different wavelengths of light interact slightly differently with a colloid or suspension. The Tyndall effect is something we see if we have particles in the range of 40 to 900 nanometers, fairly close to the wavelengths of visible light. Shorter wavelengths like blue light scatter more when they interact with these colloids or suspensions. If we light milk with a white light from the side, a greater proportion of the red light will go straight through. And if we look from the side, we'll see that the milk appears slightly blue, because a greater proportion of the blue light is scattered out the side. This is evidence of the Tyndall effect. Different wavelengths of light are being scattered to different degrees, producing a different colour than pure white. So if you see a blue tinge in your milk in the fridge, it's probably not because it's off, it's just the Tyndall effect. We can use the Tyndall effect to do a quick check of whether a liquid is a solution, a suspension, or a colloid. If light isn't absorbed by the solution, it will pass straight through. On the other hand, if it's a colloid, the light will be scattered and the liquid will appear white with a blue tinge if we are viewing it off-axis. And if we have a suspension with large enough particles, the light will still be scattered, but we won't get the Tyndall effect, so we won't get a blue tinge. The next effect we're going to look at is called thixotropy, which is the property of becoming less viscous the longer stress is applied. This is an apparently strange property that happens when colloids and suspensions are stirred. To start off with, stirring can be difficult. But after a bit more stirring, the mixture becomes easier to stir as it gets less viscous. The initial thickness is caused by the fact that particles in the suspension or colloid will stick together a little and form regular structures. As you stir, you start to break up these structures, making it easy for the particles to flow in and around each other. This is why shaking a ketchup bottle makes it easier to get the ketchup out. It helps it flow better. Now, the last general property of colloids and suspensions we're going to look at is stability. We've already mentioned that suspensions are unstable and colloids are stable. However, we haven't explored why. Firstly, unstable means that a mixture will eventually separate. It doesn't tell us how long it will take. Technically, any particle dispersion that eventually separates is a suspension. The stability of a particle dispersion will depend on many things, some of which are more subtle than others. The particle-particle interactions, the particle-solvent interactions, the solvent-solvent interactions, and so on. But here we're going to look at the two main features. If we take a particle dispersion and we make the particles larger, we're going to make it easier for those particles to stick together because it's harder to keep them suspended. This will make the suspension more unstable. And if we have exactly the same type of particle, but we change their surfaces so they attract one another more strongly, they'll stick together and fall out of solution. The mixture will be less stable. If we want to make a dispersion more stable, we can charge up the particles, making them repel each other. If they have the same type of charge, the more charge they have, the more they'll repel each other. We can affect the stability of particles by changing the temperature, the concentration of salt in solution, or changing the pH, for instance. The last thing we'll look at are the two types of method for preparing colloids and suspensions. Dispersion methods involve taking larger lumps of substance and breaking them into smaller particles, which can then be dispersed. And condensation methods involve taking smaller particles or dissolved substances and making them grow into larger particles. We can start with a solution or a colloid and produce a colloid or a suspension. We can apply the dispersion method to ground up starch, adding it to water to produce a suspension or a colloid. And we can see the condensation method in action when we bubble carbon dioxide gas through a solution of calcium hydroxide, otherwise known as lime water. A fine suspension of calcium carbonate in solid form is produced. This process also produces water, but I've left it out of the equation. Now we're going to look at a practice question. Which of the following substances or phenomena is an example of a solid aerosol, a solid dispersed through a gas? A. Mist. B. Fog. C. Paint. D. Air. Or E. Smoke. The key phrase in the question is solid aerosol, which thankfully has already been defined. It's a solid dispersed through a gas. Dispersed here means spread out. Here we have a box that contains a lump of solid surrounded by gas. The solid is concentrated in one lump, it's not dispersed. Instead, we're looking for tiny particles of solid spread throughout the gas. Now, let's look at our 5 options and see which one matches. Mist consists of fine droplets of water suspended in air, while fog is exactly the same thing but much denser, so you can't see as far. Water, under these conditions, will be a liquid, not a solid. So we're dealing with a liquid aerosol and not a solid aerosol. So these are not correct answers. Meanwhile, paints usually consist of solid particles of pigment suspended in oil or water. So paints are solid liquid mixtures, and they may be colloids or suspensions. Either way, the dispersion medium for paint is not a gas, it's a liquid, so paint is not a correct answer. The fourth option, air, is a mixture of many different gases. So we consider this a gas mixture, although you could call it a gas solution because there's a lot more nitrogen than the other gases. Air is not a correct answer because there's no solid dispersed through it. We'd have to have dusty air or smoky air for it to work. And lastly, we have smoke, which consists of fine particles produced from combustion dispersed in air. So, out of these 5 options, the only one that's an example of a solid aerosol, which is a solid dispersed through a gas, is smoke. Now, let's look at the key points. Suspensions and colloids are mixtures consisting of a dispersed phase in a dispersion medium. The dispersed phase consists of individual bubbles or particles spread out in a continuous solid, liquid or gas phase. Any mixture like this that's unstable and therefore heterogeneous is considered a suspension. Unstable means the mixture separates over time, and heterogeneous means that the composition is uneven. And this type of mixture that's also stable and homogeneous is a colloid. Suspensions and colloids are thixotropic, meaning as we stir them, they get thinner and thinner. Colloids and some fine suspensions exhibit the Tyndall effect, where they scatter some frequencies of light more than others. It's this effect that can give milk a blue tinge. And the 2 methods to produce these substances are the dispersion method, where we first make the fine particles and then spread them throughout the dispersion medium by mixing. And then there's the condensation method, where we use chemical reactions to make particles from solution or from smaller particles.